Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 18, we will talk about waste quantification and characteristics. The different concepts that we will cover are on waste quantification, waste traffic count, percentage of waste collected in Indian cities, sampling strategy, and waste characteristics. So, when we talk about waste quantification, in the earlier lectures, we have also discussed this, that once the waste is segregated and all, we really, and we need to quantify it. Either it is segregated or it is not, we need to first determine based on data that how much amount of waste is being generated. And waste, because if I don't know how much amount of waste is generated, then I will not be able to design programs for its collection and also for its further processing and treatment or even disposal. So, quantification is a prerequisite of any kind of waste management. So, waste collected and generated also varies significantly. That means in most Indian cities, not 100% waste is collected. So, some cities claim that 100% waste is being collected, but even so, there would be certain percentage which is lost along the way because of many reasons. And so, this needs to be addressed, that how much amount of waste is being generated and how much is being collected, because the gap is what we have to bridge, right? And that means those waste is actually mixing into the other activities of urban areas. For example, either people are throwing them into the fields or they are throwing them into the garbage, and it hampers other activities in urban areas. So, waste disposed at unauthorized places, vacant lots, alleys, ditches. So, always this happens. There is no way, until unless people are aware or people are themselves concerned, this cannot be stopped. Waste recovered by informal waste collectors or waste pickers, people who are coming to your house, buying the papers so that and taking them to the scrap dealers. This kind of, and plastics and other things are directly being sold from the house to this waste collectors or waste pickers, and this garbage don't enters into the waste stream. That means the municipality is not handling this garbage. So this is handled separately. So this is not part of MSWM. Then significant variation in waste collected at urban and rural areas. That means that based on the waste collection system that is designed in urban areas and just semi-rural or rural areas just outside the urban area, they will not have that kind of systems designed. So automatically the waste collection processes are totally different. There in rural areas, door-to-door collection usually is not seen, and we see that people dump their garbage somewhere and sometimes it is collected via some tractor trailers or some vehicle. So obviously the quantity of waste that is collected in rural areas is much less. So the second thing is waste needs to be, that means first of all waste is generated in urban areas, some part of it is collected, the rest is not collected. Next is waste needs to be quantified at multiple locations. It's not only quantifying the entire waste that is generated in urban areas or collected in urban areas, but also quantifying it at different locations of the city, what kind of waste is generated, because this may vary as per location to location. For example, like households, areas which have got a lot of residences, they will generate a certain type of waste and a certain quantity of waste, whereas an area with a market area or a commercial area, they will generate another kind of waste, right? So, waste generated is quantified for each of these areas or each of these generators following appropriate sampling mechanism. That means we have to have a sampling approach to determine whom we should survey or whom we should go and for whose waste we should measure and in what way we should measure it. So, that's the sampling mechanism has to be followed. And other way, waste could be also weighed at weigh bridges, at transfer stations, or along route to processing and disposal facilities. That means before the waste enters into a processing and disposal facility, we can measure the amount of the number of vehicles that are entering that facility, or the quantity of or the weight of that particular vehicle, so that we can take out the weight of the chassis, and then the rest of the weight is the weight of the waste that is being going into this particular facility. So waste at transfer stations could be measured, or waste at these facilities could be measured, and this helps us to estimate how much amount of waste is being collected but not generated, right? So this figure actually shows that this at each of these stages, that A, B, C, D, we have to measure the quantity of waste. For example, at B, like for example, waste is generated. So this is a generator. So from there, some waste goes to the waste picked up by waste pickers. So these are people directly coming to your house, buying some waste from you. So this waste is not entering into the municipal stream. The waste which is collected. Now, some people may throw some waste directly outside. So this is illegal. But the rest is collected. So, and even collection means after the collection, this waste could be taken to a segregated to a secondary storage or a processing facility. That means somewhere in the neighborhood it is coming, it is being stored for further transfer, or to a processing center where some sort of sorting and taking out of recyclable materials can happen at a local level, of course. So this is where we can measure the waste, but here the waste is coming in using maybe wheelbarrows if it is door-to-door collection, using some tractor trailers when if it is not community bin level collection. So this is where we can measure it. Then from here the waste goes into this recycling. Either it can go into this waste facility, processing facility, which could be a decentralized facility, or it could be a centralized processing facility. There could be many number of these facilities, and at each facility we can measure how much waste is arriving. So based on that, I can determine that, okay, what sort of treatment needs to be given. Like for example, if it's a decentralized composting facility, based on the quantity of waste that is coming in, I can decide how much area I require for setting up this kind of plant, right? So these kind of decisions are taken, so which requires us to quantify the waste at different levels. But at C, D, even in F, which is the landfill side where finally all the waste is going, then we can say that here the waste goes in using lorries and all, and we can measure the weight of those lorries, or waste carrying vehicles are weighed at municipal or private weighbridges, and there we can get the amount of waste that is going into this kind of facilities. But when we are talking about waste generated, in that case waste has to be sampled, and we have to determine the waste locally by using some scales or weighing some way to measure that. It is not, because waste is yet to get into a vehicle and then transported. So total waste collected, if I am using a weighing machine, and if we are using a weigh bridge, and for this kind of facilities, we can determine that total waste collected is based on the number of trips made by a vehicle multiplied by the weight of waste in that vehicle. Now, weight of waste that is collected is basically volume of the waste multiplied by density. So we know that density of waste collected in India is something around 400 to 500 kilograms per cubic meter. So if I know the size of the vehicle, the volume of the vehicle, I will be able to determine, and I know the density of the waste, I will be able to determine the weight of that particular waste, right? So this is how we calculate. But sometimes what happens, trucks carrying waste are sometimes not full and may be filled with material of lower density. So in that case, the measures that we will devise, that may be wrong. So we have to be careful about this. But again, I will stress upon that once it reaches a facility, then vehicles and all these things could be weighed. But if before it reaches a facility, or even if I am collecting waste via door-to-door collection, it's difficult to measure its weight, right? So there has to be some other procedure for that. So I will talk about that. So this figure shows you that how much amount of waste is collected in different Indian cities. So you can see that this group of cities are showing 100% collection. This include Warangal, Visakhapatnam, Vijayawada, Pimpri Chinchwad, Nasik, Kochi, Indore, Impal. So these are some of the municipalities where 100% waste is being collected. Then some municipalities where more or less 97-98% includes Navi Mumbai, Rajkot, Surat, Pune, Jaipur, Nagpur, and so on. Whereas another level, that is 90%, 88%, 87%, you can see cities like Chennai, Shimla, Rudrapur, Nagpur, Mysore, Bhopal, and so on. And finally, very, very poor situation, which is in Patna, Kota, then Allahabad, Srinagar, Amritsar, where very little amount of waste is being collected. So this is data from the World Bank. This is the source. Maybe it has been, this is recent data, 2015, 2016 data. So some of this may have changed now, but anyway, so this is the data given by this source. Maybe some discrepancies could be there, but more or less this gives us an idea that not all cities are safe. The collection system is not efficient. So in most of the many cities, we have to actually improve our collection system. And this figure actually on this side shows that in rural areas, approximately 40% of the waste is being collected. In urban areas, approximately 77% of the waste is being collected. And these figures are for South Asia. That means this is data from both India, Pakistan, and other, Bangladesh and other cities in the South Asian, this part of the world. And average waste collected is something around 50%. So you can understand that out of 100 kilograms of waste generated, 50 kilograms goes to either a processing center or to the disposal site. The rest 50 remains in the city. That is the cause of hundreds of problems, both health problems, aesthetic, cities look bad, filled up with litter, aesthetically it is displeasing, and also it creates other issues as well. It clogs the drain, it creates flooding. So this kind of problems are a result of improper collection or inefficient collection in cities, which has to be addressed. So now coming to the sampling strategy, that is, suppose I need to determine how much amount of waste is being generated. So waste is either collected in wheelbarrows by door-to-door collection, and what we can do is we can collect waste from wheelbarrows from certain households, and we can take a certain quantity of waste, because if I measure one household on a particular day, it may not have consumed a certain amount of money. Normally they consume certain amount of waste, but or they generate a certain amount of waste, but this day they have not. So it's better to take a larger size of size so that we can generalize, right? Or we can find the average waste that is generated in that particular area. So municipal solid waste composition varies both temporarily and specially. That means at different times of the day, different times of the year, at different seasons, the quantity of waste that is generated and the characteristics of this waste, these are different. Spatially, at different locations of the city is different. Similarly, as that's what I was saying, samples collected at different times of a day may be also different. Like a restaurant, in a area where there are a lot of restaurants, the kind of waste that is generated in the morning and in the evening, that will be different. Then what we need to do is, when we talk about sample survey, we determine the per capita rate of generation, but what it means is we have to do data collection over a larger period, that is a 10-day period approximately. Some variations are also there, and it has to be done 2 to 4 times a year at different seasons. During winter months, different kinds of waste is generated. During summer months, different kind of waste is generated. During rainy season, a lot of moisture is there in the waste. So character keeps on changing. So we have to do it multiple times in a year and has to be done for a 10-day period so that we get consistent values. Not only that, it's better to, once I collect the waste and all, at least take a 100 kilogram sample and then determine what is the waste content, what is the characteristics of that waste, and so on, right? So this is also important. Now, as per CPHEO guidelines, it says that we can go for both short-term and long-term plans for solid waste management. If I am going for long-term plans, the sampling strategy should be 7 days at different locations, and these are representative locations in the ULB. What it means? That means if I want to find out how much waste is generated in residential areas, I will select a few residential areas which are representative areas and then analyze the garbage that is generated over there. Similarly, if I want to determine what kind of garbage is generated by the commercial establishment, I will find some representative areas and then do the estimation over there. And then this has to be done over 3 seasons, that is summer, winter and rainy season, and this has to be repeated every 3 to 5 years, right? So for long term survey, that means we have to repeat the survey after 3 to 5 years, because it is estimated that the characteristics and the quantity of waste will change after that period. So what happens during short term plans? Like, we have to immediately do it. So the other way is to go ahead with, if for every 1 lakh people, we should collect samples from 100 sampling locations. Now, what are these sampling locations? These could be areas with low, middle and high income levels. Even though all are residential areas, but some are posh areas, some are slum areas. So the quantity or the characteristics of waste that will be generated from these areas are definitely different, because rich people will consume a certain kinds of goods, poor people will consume other kind of goods. Maybe packaging would be much less over there. So that requires us to collect samples from both the areas. Commercial areas or establishments which have a totally different nature of waste that is being generated. Institutions, hospitals, healthcare establishments generate different kinds of waste. Small and medium-sized enterprises, hotels, function halls, vegetable markets, sports complexes, places of worship, temples, mosques, they generate different kinds of waste. So we have to take samples from different areas of the city and for different category of waste generators to determine who generates what kind of waste, what quantity and what characteristics of waste. Based on this, we have to, in future, I will teach you that based on this, we have to design the collection system, design the, the way the collection vehicles would be designed. All this thing is dependent on this. So in this particular case, for short-term plans and 100 sampling locations, waste for 3 to 7 days are stored in appropriate containers and then it is weighed. So we will ask those people to store the waste, don't throw it away, store it for a few days, 3 to 7 days, and then we will measure it and we will find the average. So that means waste generated by different categories of generators in an ULB can be estimated, has to be estimated separately. Similarly, we can also combine all this waste and we can also determine component-wise waste estimate. That is, in this urban area, what percentage of waste is organic, what percentage is plastic, that also could be determined. And we can also do this component-wise. If I have an adequate sample size, then we can do component-wise estimate for also different categories of generators as well. Now, coming to the different characteristics of waste, first we have to understand what is the quantity of waste, then we have to understand what are the different characteristics of waste. And finally, after this, we will also learn about what is the composition of waste, right? But characteristics of the waste is important. Why? Because of because if I know the characteristics, it will help me to design a better storage system. It will help me to decide a better transport system. It would help me to decide what kind of resource recovery is possible and what should be disposed and what would be the environmental impact of those particular waste. So as I discussed earlier, the sample size should be at least 100 kilograms. So whenever you are getting waste from certain generators and all, at least 100 kilograms have to be taken together to determine any of these characteristics or even composition that we will discuss in subsequent lectures. So the first characteristics is the moisture content. Why is moisture content important? Moisture content determines the weight of the waste. Moisture content determines if the waste could be incinerated. Moisture content determines if the compost would be successful, right? If there is very little moisture, compost will not work. If it is too much moisture, then also it's problem for composting. So this is one characteristics which actually influence a lot of these particular stages. So moisture content is determined by as a percentage measure. It is determined by W is weight of the sample minus the air dry weight of the sample divided by the weight of the sample multiplied by 100. So we just determine what is the weight of the water and that's the moisture content of that particular waste. So this ranges from 20 to 45%. in India. Sometimes it's even more than this. So usually in dry areas we will get moisture content around 20%. In wet season, in other areas which is very wet, we can get around 45 or even more. And weight of MSW depends on moisture content that we discussed. Moisture content determines incineration feasibility. That means if the waste is wet, then we cannot burn it, or actually we will require a lot of more energy to burn it, which will make it unfeasible. Waste generated in developing countries has more organic content than industrialized countries, and moisture content is generally high in waste containing more organic content. So more wet, that's why we call it wet waste, right? Because the organic waste has got a lot of water in it. The second characteristic is size of the waste. Waste that is generated also is of different sizes. As you can see that we can have waste which includes textile, cardboards, plastic films, other paper. So there could be other types as well, but each of them are of different size. So to determine that size, we have to put the waste through some sort of screens, or some sort of sieve, right, through which the waste will pass. So usually it is determined with the use of a set of screens with square openings of size equally, usually of 100 centimeter, 50 centimeter, 25 centimeter. So we will say what percentage of waste has passed through 25 centimeter. Beyond that, what percentage will pass through 50 centimeter and what percentage will pass through 100 centimeter. Now, if the amount of percentage which is passing through 25 centimeter is low, that means the size of, like suppose 75% of waste passes through 25 centimeters. So 25% doesn't passes. So 25% out of that, maybe 10% passes through 50, and the rest is even larger than 50, and maybe even 5% passes through 100, means 5% waste is even beyond 100 centimeter size. So this helps us to determine that is there a need for shredding of the waste, or should I make it in smaller sizes, right? So this affects both the collection process, and it also determines what should be the vehicle size to collect this kind of large waste, right? Transportation, processing, treatment and disposal of waste. Like for example, I will teach you how to design landfills. If waste is very large, then it will, after a day's disposal of waste, it will stick out. We will not be able to cover it using mud or using soil. After every day waste is put into a landfill, we cover it with soil, right? But if the waste is sticking out because it's of large size, we can't do it. So there is a need to shred the waste. So that's why this characteristic is important. Then mechanical properties. This is also important for proper design of processing plants, final disposal facilities and so on. So what is, when we have got unsorted waste or we have got dry waste which needs to be further sorted, we take them through a mechanical process sometimes, and where the there may be a vibrating bed, or there may be a magnetic separator which separates out the metals and all, and then there are vibrating beds which separates out waste of different density or weight and so on, right? So in this way we can do a lot of processing, and obviously the properties of waste, like what is the strength of that material, this kind of things actually helps us in designing what sort of material processes we should design in our processing plants, or what sort of mechanical system we have to design. So that's why mechanical properties are also important. Then comes density of waste. Density of waste is measured in kg per meter cube or mass per unit volume, and it determines the storage and transportation volume requirements. We have already discussed this, and this is typically the value in India, 400 to 500 kilograms. But of course, we can use refuse compactors or compactor bins. Before we transport the waste, we can use these compactor bins or refuse compactors, which will further compact it, get water out, or get compress. If there are a lot of plastics, that will also get compressed, and this has to be then transported, and so we can utilize less number of trips. Otherwise we would require more number of trips to transport the same weight of waste. So you can see this in this particular image. We are showing you a refuse compactor. So this is just like a mechanical garbage bin which has a system to lift the garbage and throw it inside, and then there is a compactor inside, or it's a hydraulic press which presses on the garbage, and it makes it, it squeezes the water and squeezes the air out of that particular garbage, and makes it more compact, right? So compactors are required for low density waste, usually for packaging waste, plastic waste and so on, and where we have to achieve at least a compaction ratio of 2:5:1. That means we have to make the waste more 2.5 times compact. If it is not so, then probably this would be not economically feasible, right? Because this kind of equipment also costs a lot of money. So how do I measure the bulk density of waste? It's pretty easy. Take two containers. You can take two wooden boxes for waste, one of 1 meter cube and one of 1 feet cube, right? So obviously this one is the much smaller container. Why it is small? So that it's easy to handle. So we should also have a spring balance. The spring balance is something where we hang a particular container. We will hang that 1 feet cube container, and using the spring balance we can measure what is the weight of that. So this spring balance should have a capacity of 50 kilograms, and what we do is first the composite sample that we collect from different the 100 kg sample that we collect, that will be first filled in a small box, this small one, and then we will weigh that using that spring balance. We will record that weight and then put it in the larger box. We keep on doing this till the larger box is filled, and we don't compact it, though we don't press it. And so based on the weight that is being recorded, we add that up and we get the overall density of that particular waste, right? So we can determine the weight of the waste, total waste, and because we know the total volume is 1 meter cube, and we can determine what is the density of the waste. Now, this entire process is repeated 3 times, and we take the average to come to the final average density of waste in that particular area. Then after that comes the thermal properties, which primarily we are talking about the calorific value of waste. So we have already discussed this. The unit is kilojoule per kilogram, and it is the heat generated from combusting a unit weight of the waste. So 1 kilogram of waste, if you burn it, what kind of heat would be generated? Usually we use a bomb calorimeter for measuring calorific value, and it determines the feasibility of energy production, this calorific value, and calorific value of landfill gases. Landfill gas is methane. A lot of methane is generated in landfills. So calorific value of landfill gases is also determined and depends on the methane content, right, of that particular landfill. So this is also determined. Then biochemical characteristics of waste. This include a lot of all the chemical properties, because this also determines what should be the kind of treatment, what sort of biological treatment that could be also done, what sort of non-biological chemical treatment could be done, and so on. So what these chemical properties include? This is pH of waste, nitrogen, phosphorus, potassium content of waste, total organic carbon, CN ratio, calorific value, and so on. So you will see that subsequently when we discuss further, you will see where we are using CN ratio to determine the ratio between carbon and nitrogen content in waste. We are totally determining this nitrogen, phosphorus, potassium to determine what kind of elements or what kind of minerals remain in the waste, right? So then coming to biochemical properties, we can look into the, particularly for organic waste, we can look into carbohydrate content, protein content, natural fiber, biodegradable factor, because these are sometimes play a role in determining what subsequent processes we will undertake. Toxicity of waste, toxicity profile of MSW, how much heavy metals, persistent organic pollutants, pesticide, insecticide remains in waste, and also toxicity characteristics, leaching procedure, which is the procedure which is followed for determining toxicity profile of municipal solid waste. So these are some of the references you can study.